All right, chapter 1, problem 7. There's a lawnmower. Look at that, there it is. There is a lawnmower with the dimensions given. Let me read the problem. Here we go. Shown in figure P 1.7, which I've got in the corner, but that's really kind of too small to see, weighs 35 pounds. Determine the force P required to move the mower at a constant speed and velocity, and the forces exerted on the front and rear wheels by the inclined surface. All right, maybe I'll see if we can make this bigger a sec. Actually, I have to stop the recording. There. And now we should be able to look at that a little bit better. One thing that I want you to notice, and I can't really highlight it on the screen, but that is that the force P goes through the center of the wheel, the rear wheel, which is not in line. That is not in line with the CG for the vehicle. It is 4 inches below if we work that problem, if we start thinking about that. So let's start cutting through the problem. All right, so first thing we're gonna do, what's our problem? So we are looking to find the force P, find P for constant speed. And find the reaction forces. All right. We'll call this part A, we'll call that part B. So for part A, what do we need to know? What do we need to know? Well, we start redrawing that picture a little bit. I've got this going through my rear wheel, going through my front wheel, and I had a CG here. And I can draw more, but I don't know that it's really worth it. Now, is that a free body diagram? I got a weight force acting down. Actually, these forces don't act that way. These forces act this way, normal to the ground. Which, you know what, that's why you don't use pen, but I tried using pencil and I just didn't get the contrast. So you ready? Here we go. Start over. I got that, goes back to my rear wheel. My rear wheel is at some angle to this. That's got an angle like that. That. And I've got a CG which is acting down. Now, someplace I've got to start defining some angles. That is 30 degrees. I can see that from my diagram on the side. And I can also see that this compared to horizontal is 15 degrees. I'm going to label that. That's my weight force. That's the force in the rear. That's the force in the front. I'll make sure this is still labeled P. Now, the reason I'm pausing, the reason I redrew everything is I want you to think carefully about how do we choose our coordinate system. I think what you're going to find is by being masters of the coordinate system, we can make the problem a lot easier or a lot harder. And in this case, I'm going to put a coordinate system that looks like this. It is aligned with the mower. It is not aligned with the gravity force. Normally we would draw that gravity vector being in the negative y direction. In this case, I'm not. It's going to have some funny angle. But that's, I think, going to make this easier because now I think this becomes easier. If I do a sum of the forces in the x direction, there is no force, there's no x component. Those are only in the y direction. So now I get a minus the weight component times some angle. Well, I'm going to tell you it's sine of 15 degrees. It's if this angle goes to 0, if this goes to flat, the angle goes to 0, then it would be sine of 0, which would be 1, would be all set, but it's not. It's sine of 15, so I got that right. And then I've got this angle, P, or this force component, P, and that is going to be plus P times, well, if that angle goes to 90, then that goes to 1, so that would be cosine. Sorry, I'm in the x direction. If that angle goes to 0, it goes to 1, so it's cosine of 0. So it's P cosine of 30. Now, some of you may be faster at that and slower at that. That is something that we've got to just get ourselves back into. But that force in the x direction and solving the trig functions, I don't want to say it has to be second nature, but it is. We've got to just get back into that skill again. You had it in the statics and dynamics class. We just have to shake off some rust. So that means P is equal to W times sine 15 divided by cosine of 30, and we can crank that all out and get 10.5 pounds. How's that? That gets us P. All right. Now what do we want to solve for? Well, we still need, according to page 1, we still need our reaction forces. This is the solution to A. B, the reaction forces. How do we want to do that? We have two more equations. We have two unknowns and two more equations. Which one do you want to pick on first? Yeah, okay, sure. Some of the moments about the rear wheel are equal to 0, it's static, are equal to P acts through the rear wheel, so that goes away. The force from the rear acts through the rear wheel, so that goes away. So I get the weight force, and I'm going to use, should we use the same coordinate system? Sure, we can use the same coordinate system. If I use the same coordinate system, now we're going to have to start getting fancy with directions and everything else. The force that's going in that direction, right, is W cosine of 15 degrees. And then I need to know where that CG is. And I didn't copy those dimensions down. I have to look back at my diagram. You can see, kind of, I can see it, but it's on a big screen next to me. That's 13 inches is that distance from here to here. And this distance, I'll put it in right now since we're dealing with it, that's 14 inches. All right. That force F, so that's going to be plus the force in the front times now the full distance, which is 27 inches. All right. Now, here's where I'm going to tell you I got in trouble the first time I solved this problem. I broke this up into this force into that direction, but there's one more component, and that is this force in this direction. And that was the reason why I pointed out that there's a difference of 4 inches here. It adds one more term. And this is also going to be a plus term. This is plus W, and then it's sine of 15, because that's this part of it. All right. And then that distance is now 4 inches. And without that, you really struggle because you're a little bit off, but you're not a ton off. But you're enough off that it's bad. Bad. So that is going to give us the force in the front equal to 14.9 pounds. All right. I'll pause a sec. All right, then lastly, I have to change pages to work the next part. But to get the reaction force in the front, I'm simply going to do sum of the forces in y direction are equal to, put this down below here, in the y direction, I've got P times sine of 30, and that's going to be, I'm pushing down, it's negative. And then I've got my weight function, we'll just pick this one off, that's going down, that is going to be minus the weight times cosine of 15. And then I've got the force in the rear and the force in the front, and those are both acting up. Force in the front plus the force in the rear. And then I can go through and solve all of those. The force in the rear is equal to, and I'm going to jump a couple steps, but that's equal to 24.2 pounds. Yeah. Ta-da! There you go. Any big assumptions? Any big problems? Any big things that we skip? No, it's a static problem. Here's our governing equation here. This is sum of the forces is equal to 0, or sum of the moments is equal to 0. That's our driving equation. We worked all of our problems through. We got a complete equation. Then we did some rearranging. Maybe if moving forward, I'll start doing some of the rearranging and some of the algebra, but for today, I think we're in good shape. Hope you're doing well. Take care.